Okay, good evening everyone and welcome to this evening's inaugural lecture, the very first inaugural lecture of this academic year. And we're gathered here tonight to celebrate the appointment of Sharyn O'Halloran as the SALI Chair of Political Economy. For those of you who don't know me, but I think I pretty much know everybody in the audience, but I'm Gail McElroy, I'm Dean of the Faculty. A particular warm welcome to the Provost, Dr. Linda Doyle, Professor Orla Shields, and also to the Head of School of Social Sciences and Philosophy, Paul O'Grady, the Head of Economics, Gaia Narciso, and the Head of Political Science, Peter Stone. For those of you for whom it is your first inaugural, I see some PhD students here. Inaugural lectures are a significant event in an academic's career. They provide newly appointed professors with the opportunity to showcase their research. And there's a very exciting topic here this evening. How can artificial intelligence improve public policy? Very apposite, so that's great. And they're slightly ceremonial, so we're both wearing gowns, just the traditional, but we can't beat the Vice Provost, former Vice Provost, who's here in black tie. We're all a bit underdressed. So both economics and political science have been taught in Trinity, actually, surprisingly, since the mid-19th century, though it wasn't until 1932 that a moderatorship in economics and political science was established, at which stage both disciplines kind of moved centre field from the periphery. And since then, as you will know, they've both proven very, very popular, with such high points courses as BESS and a flagship course, PPES, some of the largest junior fresh classes in the university, with over 700 people taking one form of economics or another in the first year, and close to 600 political science. The first professorship of economics, coincidentally also a professorship in political economy, was established in 1832 from an endowment by the reforming Archbishop of Dublin, Church of Ireland Archbishop Richard Wakely. The post was established on a part-time basis for 5 years with a stipend of £100 per annum, which the Archbishop of Dublin, Professor Dr. Wakely, himself paid until his death rather generously. We no longer have to do that. We don't have to take it out of our pockets. And while government and political theory were long taught in TCD, the first full-time lectureship in political science, though, wasn't established until 1948, and the first named chair in the subject was created in 1960 and was held by, for many years by the rather impressive political scientist Basil Chubb. However, there have been no other named chairs in either discipline in the last 60 years. So we were, and both of them, I would like to say, are also currently, unfortunately, empty. So we're particularly pleased with the establishment of this new SALI chair in political economy. It's a great cause for celebration. These SALI chairs, just as a bit of background, were established by the Higher Education Authority and Mary Mitchell O'Connor in 2019 to address gender underrepresentation at senior level in Irish universities and higher education institutes in general. As recently as 2018, only 26% of full chairs in Ireland were held by women, compared with 52% of assistant professors / lecturers. Though I'm happy to say Trinity has 35% of its personal chairs and established chairs held by women, so as always, we're above average. The School of Social Science and Philosophy, Gaia Narciso and Will Phelan at the time, successfully bid for one of these 20 SALI posts in the first round, and this is why we're here this evening. And there was also one successfully achieved by the School of Mathematics, which has also been filled. Now to tonight's speaker, Professor Sharyn O'Halloran. Sharyn O'Halloran is appropriately both a political scientist and economist by training. She obtained her BA in Economics and Political Science from UCSD, from which she also received her MA and PhD. Before joining Trinity, Sharyn was the George Blumenthal Professor of Political Economics and International and Public Affairs at Columbia University, where she also served as Vice Dean, Senior Vice Dean and Chief Academic Officer at the School of Professional Studies, and she also chaired the University Senate. Dr. O'Halloran's research analyses the political economy of international trade and finance, regulation and institutional reform, economic growth and democratic transitions, and also the political representation of minorities. She's had a very prolific career. She's written over 50 articles and 4 books, with the most recent one from 2019 entitled After the Crash, Financial Crisis and Regulatory Responses. And we know rather more than we'd like to know about that in Ireland. Tonight she will deliver a talk entitled How Can Artificial Intelligence Improve Public Policy? And with that, I hand over to Professor Halloran.
Thank you. Thank you very much, Dale. Do you need to see? Is it working? Just refresh. So, all right. Well, good evening. And I am deeply grateful for the many distinguished academic colleagues, friends, and family from all over the world joining us this evening. And special thanks to Valerie for arranging this. I appreciate it. I am honored to be the inaugural recipient of the SALI Professorship in Political Science and Political Economy, the first named chair professorship held by a female in Trinity's 430 years. And the Strategic Academic Leadership Initiative, or the SALI Professorship, was the vision of the Ministry of Higher Education to support the advancement of women leaders in academics. But I'm not alone. I am humbled to be among the many outstanding female academics who now lead Trinity, including our first female provost and president, Linda Doyle. So, thank you. So tonight is a night of firsts. So the research university at its very core raises questions and solves problems. And tonight I'm going to ask a question. How can artificial intelligence improve public policy? Now, in giving these kinds of talks, it is always good to keep a sense of perspective. And Albert Einstein aptly stated that everything that can be counted does not necessarily count, and everything that counts cannot necessarily be counted. And with that in mind, I'd like to address the question of how artificial intelligence can improve public policy by looking at it in 3 steps. First, I would like to ask, what is the problem? What are we trying to solve here? And here we were talking about government facing increased complexity and policy uncertainty. Scope is changing, it's expanding, its environment, economic and political environment is very polarized. And so is artificial intelligence a solution to this? And we have to realize that artificial intelligence isn't just something that comes out of the air. It is a set of tools, well-developed tools, that are usually used to apply to solve problems. And then I want to address this and apply artificial intelligence to 2 areas, 2 examples. And aptly, they're going to be looking at financial market regulation. And first example, I'm going to use text analysis and predictive algorithms to classify laws along lines of regulatory discretion. And in the second case, we're going to use simulation and predictive models to analyze the impact of regulation on systemic risk. Now, to address this question, we're going to need to understand the problem to be solved. So, again, we have governments facing increased complexity and policy uncertainty, and the drivers that we see are expanding scope, limited resources, that's a perennial, but the demands for accountability and transparency have increased and are much more vocal. We have a deluge of data in some cases and sparsity of data in others, and we have conflicting policy goals and mandates. In this environment, it's difficult to evaluate the impact of public policy. So just as an illustration, here we have a comparison between the United Kingdom and United States regulatory restrictions, and that's the solid line moving up. And you can see over time that regulatory restrictions have just increased. But we also see in the bar charts that the notion of policy uncertainty and complexity has really not responded to the increase in regulations. That increasing regulations has not abated these policy uncertainties. And in fact, the growing number of regulations can actually hamstring public policymakers and limit the solution space. So the question is, given these drivers, how can artificial intelligence tools offer a possible solution? So let's start off with a baseline question. What is AI? And there are many definitions, but the simplest and perhaps most apt comes from IBM, which is artificial intelligence is a set of tools to learn from data by identifying patterns. And when you look at artificial intelligence, again, it's not a discipline of itself, but rather it's highly interdisciplinary. It pulls from computational science, statistics and mathematics, creating an area of data science, but it's all applied to a particular domain, a domain or a problem to be solved. And in this case, then, by combining these disciplines, you are being able to use these tools to enhance human decision-making and problem-solving. This is a problem-solving driven area. So why now? Why are we see every government saying that we are adapting AI? They're putting out white papers. They're saying this is the time. AI is here to stay. Ireland was a forerunner in this in 2021 that actually put out its white paper, explained how they were going to use AI and the guidelines around it. But why now? Why are we seeing all of this? What's important to realize is that these are emerging technologies are more accessible. Machine learning, natural language processing, deep learning, and so forth. They're now using these tools, we have a whole set of solution spaces, specifically applied most readily in business. And in this case now, since it's been tried and true in a particular domain, it's now being readily applied to government. In addition to having solutions, we also have these tools are much more powerful and transparent. Okay. In this case, then, there are other drivers here. One, we're seeing that the development of these tools are now in an open source. That is, you can get the code readily. It's being developed in collaboration with industry, academics, and regulators. And they're moving towards shared standards from which you can develop and improve upon the tools. Now, in making all these statements, I want to be very clear that these AI tools are not new. Natural language processing has been used since the 1950s. And if you want to think about it, logistical and linear regression are the simplest forms of machine learning algorithms. And these are tools that we use all the time. But it's the emerging technologies and in the solution space that is new and different from now, and why it makes it much more adaptable to public policy. So how can AI help? This is the basic structure of public policy making. There's 5 steps, if I was to give you my introductory discussion here, but with problem identification, formulation, policy adoption, implementation, and evaluation. And we can think then, how can these tools help along the way? Let me be very clear. Each one of these processes has an enormous amount of research and people actively engaged in analyzing them. So it's not that AI replaces that analysis or replaces those domain experts, but it asks how can it augment or improve the decision making along with that. So when we think of problem identification, we can think of text analysis to detect new issues or sentiments around existing issues. For policy formulation, we have natural language processing and machine learning to improve measures and conduct scenario testing. And with policy adoption, you can think of data visualization to enable data-driven decision-making for coalition building around legislation. Policy implementation, you can use simulation and reinforced learning to help predict policies before they're implemented, and giving those benchmarks, you can have real-time feedback to evaluate the outcomes when you've actually implemented those policies. In this case, then, AI tools can support all stages of the policy process. And I'm going to look at two particular areas. I'm going to use AI tools to guide regulatory discretion. That is, I'm going to focus on the policy formation process. And then I'm going to use, in a second example, I'm going to use AI tools to predict the impact of policy before implementation. Now, in all these things, there are caveats, right? And I want to be very clear. When you adopt new technology to something as fundamental as government decision-making and public policy, you want to proceed with care. And to disparage an old adage, a tool is only as good as its user. AI tools reflect bias embedded in the data used to train the algorithms. And if you automate automated decision-making without ethical checks and balances, will only exasperate those biases. In fact, just magnify them tenfold. The opacity of data and assumptions and models can limit interpretability, and so you need domain experts. When you use AI, you're not, and automation, you're not getting rid of your policy experts. In fact, you need policy experts at the design of the program, of the tool, at the implementation of the tool, and at the ongoing and oversight of the tool. In this case, we also need to realize AI tools identify correlations in the data. This is not tools that are used to make inferential causation or test hypotheses, but rather to find patterns that are new and interesting that can be explored and analyzed. With that, then, we can move to a set of examples. And the two applications of AI are going to be to financial market regulation. And this is coming from my own work. And in the first case, we'll be measuring regulatory discretion. And in the second, predicting the impact of regulation on systemic risk. So the first case of regulatory discretion, we're looking at policy formation. And in the second case of systemic risk, we're looking at policy implementation. I think we can all agree that the financial crisis was a formative event in many people's lives, one that we are still living through, and Ireland actually is continuing to repay those debts for nationalizing some of the banks. But it was a perfect storm of failures. And possible causes, we could name many, but they include Wall Street, and regulators, and rating agencies. They all played a role. And the response of governments was to regulate to reduce financial market risk, introducing a number of regulations and rules such as capital buffers, regulatory requirements, consumer protection laws, and so on. Now, policymakers in issuing statutes that mandated regulators to regulate, to write rules, they left those rules, those decisions of how to regulate, actually to regulators, how to design those rules. In fact, in Dodd-Frank, there were over 300 rules that were delegated to regulators. Correct? And if you remember, the Volcker rule was over 300 pages long. Actually, it was rescinded in the end. But the debate then for public policymakers and policy and analysts is how to design these regulations, that dictate how agencies can actually write the rules and how much leeway they have in setting policy. This is a debate around regulatory discretion. And the debate really stems from a feeling that many regulators fail to oversee the financial institutions that brought down the economy. And when we say that, the effects of sovereign debt, of individual lives, of the disruptions into the labor force were extraordinary and continue to actually live out long past the end of the financial crisis. And some claim that regulators had too little authority to regulate. Okay? They didn't have the ability to regulate. This was Geithner's complaint, the Treasury, the head of Treasury at the time. Others claimed that regulators had the authority but failed to use the policy tools. Now, a very notion of key political economy idea that comes from a Madisonian discussion is really that formulating good public policy requires that you give regulators or agencies enough authority to do the job that you've mandated them to do, but that you limit the potential of abuse or getting, in this case, industry capture. So let's think about how we can measure discretion or regulatory discretion and how we can solve this debate. In this case, then, we're going to treat laws as data. Now, the traditional approach to measuring discretion is using observational coding, where you compile data on financial regulation laws, and here we're looking at U.S. financial regulation laws from 1952 to 2010. I've actually done this also for EU regulation laws, but it's a much smaller band. And then you code the number of provisions that delegate substantive authority and the procedural constraints associated with that delegated authority. And you use manual coding rubrics that look something like this. And you train many graduate students to go ahead and read these laws and fill them out. And from this, then, we're able to have a relationship of delegation and constraints that can be used to define and construct a discretion index. There are many limitations to using observational coding for these types of laws. One is extremely time-consuming. We are talking about hundreds of laws being coded multiple times, and some of these laws are 1,000 pages long. No matter how well you train your team, there's always going to be issues around intercodal reliability. These laws have 30,000 words, and you're annotating them, in essence. And manual coding, especially from a rubric, may miss hidden patterns that are going to be important for understanding how regulation should be used. So a possible solution is to use natural language processing and machine learning to automatically classify laws along regulatory discretion. So here's computational analysis then. So we're going to use natural language processing and machine learning. Those are two elements that we're going to be increasing. This is the top line is just an abstract of what you're really doing here in the process here. You're trying to find patterns. And so in this case, you have a text that's being imported. You're going to create a vector of features. Those are words. And those words are going to be combined to be predictive of classifying a law as to whether along some discretion line, a level of discretion. So that's the idea. When applying these two laws, there's a four-step process that's used. In the first step, you get a document, and you take the text and you digitize it. You're going to use natural language processing to define features, and then you're going to use machine learning tools to get and algorithms, and then you're going to classify the laws. In this case, we're classifying from 1 to 5, low to high. So you convert your law to text. You assemble document corpus. There's a set of processes of pre-processing that you go through, cleaning and tokenizing, normalizing vocabularies, and so on. You get a vector of representations, and there are associated weights with that. You then develop the algorithm that's going to maximize the laws correctly predicted into each of those categories based on the training set or benchmark that you've established of what's the truth. And then you apply, in this case, a feature selection model to classify the laws into discretion categories. When you do this, and this is using just a naive Bayes model, which is the simplest learning algorithm that you can, doesn't impose any structure. You see that when you move from manual coding the laws to increasing it and computationally using just the laws and the features, to combining them in the Model 4, where you use the most predictive features in both the manual and in the computational models, you're able to improve your prediction by 81%. So in this case, then, what's important to realize is the best model includes both manual and computational features. That is, you can't get away from doing at least some manual coding, because that's going to be your baseline. And you're capturing important things, elements that come from theory, that tell us how to think about these issues. So combining manual coding with feature selection models provides a method, a way, to automatically code these laws for regular discretion. It reduces time and expense, and improves the accuracy of the prediction. And these tools then enhance policy formation by providing robust measures of discretion discretionary authority that is granted to regulators. And so when we want to resolve this debate, we need to know how much authority these laws delegated to regulators, and this is a means to do so. The second example is on systemic risk. And here we're looking at the policy implementation process. Just a little drama in the middle of a presentation. So what we want to do now is figure out a way to avoid global economic meltdowns. Okay? Now, the current solution is that we're going to use our expert judgment. Okay? We have experts that can predict the impact of a regulation and evaluate its effectiveness after the implementation on a real system. And this was embodied in Janet Yellen's, when she was the head of the Federal Reserve, the U.S. Federal Reserve, when we were talking about implementing central clearing. And the idea was, well, we don't really know what central clearing is going to do, but, you know, just because we don't know everything doesn't mean we shouldn't implement it. So this is a case where it would have been really nice, and I have a paper on central clearing, but it would have been really nice to have some good benchmarks to think about how central clearing should be implemented before we went ahead and implemented central clearing. We're going to be looking at something different. And this is in the AI approach, or the proposed solution that you're going to look at, is going to rely on predictive models to estimate the impact of financial regulation and evaluate its effectiveness before implementation. Okay. We're going to do this in 2 steps. We're going to automatically classify the regulations as systemically risk reducing or not, right, for a single financial system. And then we're going to randomly generate financial systems and then evaluate the impact of regulations on that system as well. So the approach. In order to classify a regulation as systemically risk reducing, you have to find a metric to measure systemic risk, and this metric has to be able to be used in any given financial system. And then you have to quantify the impact of the regulation as measured by this metric. All right? And just to give you a sense of what this looks like, we do it in 3 parts. The input into the analysis is a financial regulation, and we're going to be looking here at collateralization of derivative trades, but for financial regulation, a structured financial system. Then we're going to use simulation, where we'll compute the impact of risk in basically derivative trades without any regulation. Then we're going to compute the risk once we introduce the regulation on that financial system. And then we're going to evaluate the systemic risk metrics in the financial system and compare both one without the benchmark and then with one. And this gives. Okay. So how do we simulate risk? So we're going to have to calculate the systemic metric and then and then evaluate the regulation's impact. Again, here we're going to be looking at collateralization. Collateralization is like when you buy a house, you put a down payment down, right? So the more, the debt to value, the less debt to value, the less risk that you're going to default. And this is very similar to that. So we're going to look at, to do this, we need to look at three measures, which is the first is the risk that we're going to measure is what's called counterparty credit risk. This is the risk that's associated with derivatives. We're going to use a particular measure, and this is the measure that's standard in the European Union, which is effective expected positive exposure. And then we're going to use a systemic risk engine to compute the impact on both bank trades and at the system as well. I have pictures, don't worry. So counterparty credit risk is just the counterparty risk that happens or the probability that a counterparty will default before the transaction is ended. And we can see this in a set of derivatives, just what this is. And why this matters is that this is trillions of dollars of notional value. Okay, so, and if you remember, it was the derivatives that were sort of brought everything down in their arcane method of tranching the risks of each of the housing. And you also see here is the credit exposure, how much exposed credit you see as a result of these net-net trades. Okay, and one thing that you should notice here is that on the bottom line, the bar chart, that's remained relatively constant despite changes in regulation. The second thing is EEP, and you should just think of this is the cost of resolution of given the loss, a loss given failure, or the probability of failure, and the answer is how much will it cost you to resolve another global financial crisis, okay? And this is a measure of that, and it measures it at the 1 year out. And the second is the systemic risk engine. And here, it's important to realize that we're going to be looking at what artificial intelligence does to us in a number of ways. One, we're going to be using synthetic data, which is a sample of data derived from real distributions. We're going to be given these inputs, we can forecast both the pricing and exposure trends, and then we can use computational analytics to roll up and aggregate the sparse, high-dimensional data that we see in the individual bank trades. And then we're going to do scenario testing and predicting the outcomes. Again, I have a picture. And then we're going to do data visualization. All right? Here's a pretty picture. So this is what the engine looks like. You have your inputs into the system generator. You have a financial of trades. This is the trades at the bank rate level. They get rolled up, and you get a regulation included. You're then going to have in the financial systems, when it's aggregated up, the different types of trades that go on and give weights to the risks. You're going to validate and calibrate and then visualize. All right. What you're trying to do is combine predictive algorithms and simulation to optimize the regulation under various scenarios before implementation. So, what does that look like? All right. Again, derivative exposures we have here. We have the bank. We understand that these are contracts that have very long maturity rates. Banks are required to actually post collateral, depending on the level, initial margin and variation margin. And the expert judgment on this says that collateralization reduces systemic risk, that is total exposures, as well as the concentration risk or the distribution risk over the system. So we're going to move in our simulation from the baseline of no collateralization all the way down to full collateralization, and we're going to look at a sample of example of the financial system. And here we're only going to look at 6 counterparties. So, pictures. So what are the effects of this? We see that as you move from no collateralization to full collateralization, you drastically reduce the total risk of the system, right? But that is the cost of resolution if the system fails. You also see that the total risk of all the counterparties actually is significantly reduced, but the distribution of risk or the concentration of the risk is virtually unaffected. And if you believe, as Larry Summers did when he was the acting U.S. Treasurer, that derivatives play a fundamental role in distributing risk throughout the system, so you don't wind up getting bubbles or these concentrations of risk that can lead to failure, then in fact, if you impose collateralization, you are not going to be addressing that particular problem. So while collateralization is effective in reducing the total cost of exposure or failure of the system, it's not effective in mitigating or dispersing out the risk into different ways or changing concentration risk. The other good thing about going through the steps the way I did and building up the way I did is that you can then have a bunch of data visualization tools from which you can then do scenario testing. And this is just a systemic risk dashboard. And you can see in the left-hand corner the financial system counterparties exposure, and you can change the weights around and where you're putting the different types of risk between counterparties and see if that alters the outcome. You can then look at the impact of collateralization or any regulation on systemic risk, and then as well as the concentration risk and the risk about counterparties. So this is all done prior to, say, implementing a policy. And if you want to solve a particular problem, then it's really important to have these types of tools to aid policymakers in making that decision. Displays the impact for the financial systems and banks and the concentration and distribution of risk. So these tools provide you with benchmark predictions, right, to aid policymakers in policy implementation themselves. Okay. So what's the outlook? What's the future of AI for public policy? Now according to Rees, a real danger of AI in government is that scholars and practitioners are going to make technological decisions without understanding or with reference to the implications of governance of the administrative state. I would take it a step further, and that applying AI tools can have a significant impact on social welfare and economic efficiency. And so we need to be mindful when we're automating decisions and make sure that we actually have a benchmark or a goal in which we're trying to achieve. I think that this leads to a lot of rethinking of how we use models and how we use measures and so forth in public policy and what